Everybody likes cookies. But have you wondered that when you stick cookie dough into an oven, and magically you get a plate of warm, gooey cookies? Except it's not magic, it's science. Today, I'm going to explore how the different components, ingredients, and mixtures of cookie can be related to chemistry. When we look into the oven closely, it looks like a monster coming alive. For a moment, it sits there. Then, ripples move across its surface. Particles vibrate faster and faster as the temperature of the oven increases. It expands and bursts with weird boils. It triples in volume. Its color darkens, and its surface hardens into rough and cracky surface. Then, the kitchen timer dings. Your cookie is ready. What happened inside that oven? Don't let the apron deceive you. Bakers are mad scientists. Transformation of cookie dough. When you slide a pan into the oven, you are setting off a series of chemical reactions that transform one substance, dough, into another, cookies. When a dough reaches 92 degrees Fahrenheit, which is 33 degrees Celsius, the butter inside melts, causing the dough to start spreading out. Butter is an emulsion, mixture of two substances that don't want to stay together. In this case, water and fats, along with some dairy solids that help hold them together. As butter melts, its trapped water is released, and as the cookie gets hotter, the water droplets boil to steam. It pushes against the dough from the inside, trying to escape through the cookie walls. Yes, just like the aliens. A question popped up in my mind. Why don't fats mix with water? Well, fats are composed of carbons and hydrogens, which are very hydrophobic. Hydrophobic molecules are not polar and will segregate from water, which is polar. Fats have a double bond between carbons. This makes it nonpolar, and only polar substances mix with water. At 144 degrees Fahrenheit, which is 62 degrees Celsius, changes begin in the proteins, which come mostly from the eggs in a dough. Eggs are composed of dozens of different kinds of proteins. In an egg fresh from the hen, these proteins look like coiled up balls of string. When they're exposed to heat, the protein strings unfold and get tangled up. This linked structure makes the runny egg nearly solid, giving substance to a squishy dough. The same situation occurs in boiled eggs. If you've got an uncooked egg, something like this, if you spin it, then the fluid moves around. After a while, it will slow down and stop. You can't even get it spinning that fast. Whereas if you've got a boiled egg, the properties inside have changed. The proteins have uncurled and bonded together, and that means that there is no movement inside. So when you do that spinning action, it doesn't really stop. So that's a good way of telling which is a boiled egg and which is a raw egg. Water boils away at 212 degrees Fahrenheit, which is 100 degrees Celsius. So like mud baking in the sun, cookie gets dried up and it stiffens. Cracks spread across its surface. The steam that was bubbling inside evaporates, leaving behind airy pockets that make the cookie light and flaky. The reactant that help in this process is sodium bicarbonate, or baking soda. The sodium bicarbonate reacts with acid in a dough to create carbon dioxide gas, which makes airy pockets in your cookies. Now it's nearly ready for a refreshing dunk in a cool glass of milk. Before that, one of science's tastiest reactions, caramelization, is the last reaction to take place inside your cookie. Caramelization is what happened when sugar molecules break down under high heat, form the richly sweet and slightly bitter flavor that define caramel. In fact, if your recipe calls for a 350-degree Fahrenheit oven, it will never happen. Since caramelization starts at 356 degrees Fahrenheit, which is 180 degrees Celsius. And here's another trick. You do not need that kitchen timer. Your nose is a sensitive, scientific instrument. All molecules are moving randomly in the air. Diffusion takes place, so when you smell the nutty, toasty aromas of caramelization, your cookies are ready. Grab your glass of milk, put your feet up, and reflect that science can be pretty sweet. One of the ingredients for a cookie is baking soda, which is NaHCO3, sodium bicarbonate. The coefficient is to balance the equation. When sodium bicarbonate is heated, it forms sodium carbonate and water and carbon dioxide. The carbon dioxide causes bubbles. However, the bubbles do not become big because of the salt NaCl slows down